Welcome you all. Great to see so many people here, and we do realize that there's one thing standing between us and your lunch, and that will be us. So we'll try to keep it within the time box, and given that this talk is all about speeding up your build, I think we have a bar to achieve. We, that is actually Benjamin, who is a PMC for Apache Zero and for Apache Maven, and myself, Maarten, who is a PMC for Apache Maven. And today we want to discuss with you how you can actually speed up your Maven build. For starters, can I see a raise of hands? How many people of you recognize this feeling like, oh man, yeah, my build's a bit slow, so you and me. I'm gonna grab one more coffee, or I'm gonna play one more game of dinosaurs in Chrome, or well, whatnot. Well, we're here to tell you today that well, you can still occasionally use that excuse, but maybe you can do other things as well. Be actually productive, actually deliver business value, and not be hindered by your build. The thing is, for many companies we've seen so far, people that actually hold the budget are reluctant to invest in improving the build. I don't know for you, but I've had many conversations with project managers, with Scrum Masters like, but that doesn't give us any business value. Well, let me surprise you, it does. It does give you business value. It was actually Hans Doctor, who works at Gradle, by the way, who wrote this report about quantifying the cost of build. And he says, we have not seen a single company where it does not pay off. In other words, every company we visited, every company that we advised, it did pay off to invest in improving, to have a faster build, a quicker feedback on the changes that you make in your project. And we're here today to discuss with you how you can actually reap those fruits as well. Before we do that, let me stress that it is very important that you don't just smash together the suggestions that we give to you today. It's not like, oh well, these folks told me that I should do whatever, so let me immediately start applying all the tricks that they shared. It all starts at the top, where we say it's very important that you start measuring your build. Once you have measurements, you have actual numbers, then you know where you can get the biggest improvement. We try to find those in the analysis phase. And once we know where the culprit is, where the bottleneck is, that's when we can start improving. And for that improving, we will give you a few practical hints today. Without further ado, it's time to start with that very first step, which is all about measuring your build. Because again, if you don't know where to improve, you're probably gonna make mistakes and maybe even worsen the outcome. For that, today we will be using an extension to Maven, which is called the OpenTelemetry extension, which acts as a time recorder for Maven. So it takes note of how long each module in your build took, how long each phase in the build took, how long each mojo in that phase took. And it will give you a graphical representation of what is consuming so much time in your build. It comes as a Maven extension, and if you're not familiar with Maven, see extensions as some kind of a plugin on steroids. So it lets you hook into Maven, and it lets you improve or actually amend upon what Maven does in a way more tight integration than a plugin could usually do. The first thing we need to do if we want to use this extension is create a .mvn extensions XML right in the root of your project. In that file, we will register the extension, and don't be fooled by the fact that it is an alpha version. I have not seen any other version by these folks that is not alpha. So it looks like alpha, but as far as I've seen so far, it does not behave like alpha. And then finally, you have to start an OpenTelemetry collector. This is essential because if you don't have that, then the extension cannot offload its data anywhere. In this demos, we will be using the Jaeger all-in-one Docker image, but there are other collectors available. This is quite a bit of a complex setup. We are deliberately using a bit more complex setup today because it works the best if you also want to visualize some things called parallel builds, which we will discuss later. But if you're looking for simpler alternatives, I've listed a few on my blog, and don't worry, we will be sharing the link to the slides afterwards, and then you can just click on those words and it will bring you to an overview. There's also simpler solutions that just generate an HTML output. Okay, to actually use the extension, you have to activate it by specifying a Maven property called hotel traces exporter OLTP. If you don't do that, the default is none, and the extension will simply do, well, you guessed it, nothing. And when you're done, you can open the OpenTelemetry webpage, or actually the Jaeger webpage, which by default looks like this. I'm sorry, this is bright screen. If you fell asleep, now you're awake again. You don't have to thank us for that, but they don't have a dark theme. We're going to the terminal. Let me see. Say again.
Full screen.
Full screen, thank you. Like so. And we're going to run our very first demo for today, which is called a measurement demo. Okay, we already did that. And as you can see, if you were really quick, you could have seen that. It says hotel traces exporters OLTP right near the top of the log. And we are going to look at the build of Apache Shiro. As I said, Benjamin is a PMC and a committer to Shiro, so we figured it would be nice to use their code for all of our demos today. And this is like where we usually go out for fun and plays, or we fetch a coffee or a tea or whatever, because, oh man, it takes so long. Are we there yet? Still not, right? Meh. But if we are lucky, we might already see some data in Jaeger. Look at that. Today, 11:36. That must be us. Yes. Great. So we get a visualization of whatever is happening in the build of Shiro-root. Bless you. Still running. I'm going to collapse it a bit so it becomes a bit more concise. We can already see some modules that are being built. We can see some modules that really are short. I mean, it doesn't really make sense to improve upon that 779 microseconds, I guess. Where are we right now? This is Shiro Hazelcast. I don't think we've...
Way past the core.
Way past core, okay, that's great. Then I'm just going to run refresh here. Like so. And even when our build is not yet done, we can already see here, this line that I highlighted. Oh wow, that out of the 1.5 minutes, we spent quite a bit of time already on Shiro Core as well as the one just below Shiro Web. Let's look at Shiro Core for a minute. We can open it up and we can see all the goals, all the plugin goals that have been executed, and we can quickly see, hey, surefire test, out of that 15 seconds, almost 10 seconds go into Shiro Core. Well, that's Shiro, of course, needs to be tested. I can highly appreciate that, but I just wish that we had a way to improve upon that. Do you happen to know something, Benjamin?
Oh, I'm glad you asked, Martin. I happen to have something prepared.
Great.
Okay, let's look at the next slide. So, this was the demo. We have parallel test execution. Sounds that this could be worth investigating. Okay, so what is it? Well, obviously it will run your tests in parallel, because it's from a single module. So it doesn't mean all the tests get collected, but from a single module, the test can be run in parallel. So when do we apply this technique? This makes sense if you do have idle cores, or some tests may be waiting for I/O, and this helps because maybe you have a large number of tests which just takes a lot of time because they are running sequentially, and the sheer number of tests will lengthen the time it takes for your module to compile and test. But sometimes you also have long-running tests, and while executing a long-running test, why not execute some other tests as well? So, of course, to every solution there are some caveats, and one of them is that your test must be parallelizable. What does this mean? Maybe your tests are not thread safe. For example, you have static methods which change the state of a global object or whatever, and if that is the case, your first build will fail miserably, but you can of course fix the test, or there are some JUnit specific annotations. One is maybe execute in the same thread, which means do not parallelize. There are some others as well. And of course, parallel tests can actually bottleneck the build. More on that later, because at the moment we are only executing one module in parallel, but if multiple tests are running in parallel from different modules, that can be a bottleneck now, because you're using up all the calls. So how do we actually execute tests in parallel? There are two solutions I want to show you. The first one is through Surefire, and the second is through JUnit Jupyter. So the first one, you have the parallel parameter in Maven. So it does have a bunch of allowed values, and of course the default is none. Why would it be something else? And you can, for example, specify classes and methods, which is, I think, pretty common, or just methods, which is also a very common value. And how do you do this? Well, the parameter is by default available as a system property, and it's just called parallel, and it will apply to Surefire and also to failsafe plugin. Or you can just use your POM.xml file, which will actually do the same thing, but with this method you can configure multiple modules differently. Okay, so what are the pros and cons of using Surefire? Well, this plugin supports both JUnit 4 and test-ng. So if you're still using JUnit 4 or test-ng, your test will be executed in parallel. And this extension is, as you know, maintained by the Maven core team. So if there's any issue, just put the issue on the mailing list or into an issue tracker of the Apache team, and it might get fixed. And there are some disadvantages as well, because all tests need to be thread safe. As I know of no annotation which could execute a test non-parallel, and well, the configuration could be a bit verbose. If you have a lot of modules and some modules cannot execute tests in parallel, you want to make sure that those get a specific extra configuration. Oh, and yes, it does not apply to JUnit Jupyter. So let's look at JUnit Jupyter. So you have three methods here, which I'm going to cover. The first one is the JUnit platform.properties file. Then you have system properties as well, and you can use Java annotations. And all of them have their pros and cons. So if you're going to use a JUnit platform properties file, you have three parameters of interest. The first one actually does enable parallel testing globally, but it doesn't do anything for you yet. You also have to set the parallel default mode, which is the second section, and a typical default value for your parallel test. And you can also execute classes in parallel, which is the third option, and you can combine all of these. So you can also do this in a POM file, for example, with the arc line. I think there's also a properties parameter in the Surefire configuration, which will also work nicely and do the very same thing. And the third option I mentioned earlier is the use of annotations. JUnit comes with a lot of annotations, and one of it is the concurrent execution annotation. And yeah, you can just slam it to each class, and the methods will execute in parallel, but not the classes. So what are the pros and cons of this approach? You have a way finer granularity of test executions. What this means is you can run single tests selectively in sequence instead of parallel with other tests. And this solution is maintained by the JUnit Jupyter team. And well, with this solution, you actually have really great IDE support. So if you use property files or annotations, IntelliJ, for example, will pick it up. So the disadvantage, this is specific to JUnit Jupyter. If you happen to have some test-ng test, or maybe Spock, if you use Groovy or others, this will not apply here. And it's a little bit harder to control from the command line, for example, if you want to do a single build with sequential test. Okay, and now I have a demo. So let's run clean first, and then I have a demo 2 parallel tests. So what this does, well, let's run another clean. Okay, the first thing we do is we will run until the Shiro core module you saw earlier, and we have the default build to just measure how long it takes again. So until we have these, I think, 15 modules compiled and tested. So this is on my machine. If you have another machine, your times can vary. And you can already see, if you're quick, if you take a very quick glance, you see lines saying running test, and then the next line will be test : and it will tell you how many tests were executed. And you see them one after the other, one after the other, one after the other. So after each running test line, there will be a line test : you will see it in the next module, probably Shiro config, because there's a long running test. Oh, here we one more. And I will stop there. Shiro core, there we go. Okay, groovy compilation, and now the tests are started. Okay, you can see it right here: running test, test run, running test, test run, running test, test run. This gives you an idea that those tests are actually executed sequentially. So after those tests have been executed, we will see the time it took to compile and test all this. Which should be done in a second. There we go, 1 minute and 27 seconds. This is pretty average for Shiro compilation. Now, let's do the following thing. If you look closely, I've been copying a lot of properties files to the modules. The JUnit platform properties were specified to execute everything in parallel. And I also used Perl to add some annotations to not run 2 tests in parallel. But the really important part is this line: copy the properties file to the corresponding resource folders. Okay, now what do you think will happen if I execute it again? It won't finish in like 30 seconds or so, because we have a lot of compilation going on. But it should be a bit faster. I expect it to be quite a bit faster. So you can already see, if you took a quick glance, but you will be able to see it in a few seconds again, that you have now multiple lines below each other: running test, running test, running test, running test, and only then there will be the line saying test run, test run, test run. So this is a good hint that the tests are actually being executed in parallel now. So there's a core module again, test compilation. And yeah, now you can see it. It's way faster, you can already feel it. Oh, a test failed. That sometimes happens, and that is very okay for my demo, because now you can see it doesn't always work. You have to fix your test, what I told you earlier. But all tests were eventually executed, and it took 55 seconds. It varies on my notebook. Sometimes it's 49 seconds. So it's already a good improvement, is it not, Martin?
Yeah, I like this.
So, okay, we have improved the tests. So, Martin, do you think there's more to parallelize?
Well, I'm glad you asked, Benjamin. Really glad you asked. Because yes, of course, we can use the same trick once more. And for that, I'm going to introduce you to a friendly daemon. So I know there's unfriendly daemons, but this one really is friendly to us. The Maven Demon. Let's get started. The Maven Demon is a method that you can use to actually improve your Maven startup time as well as execution time by using a daemon process. And the daemon process is something that is running in the background, and then there's a CLI tool that helps you interact with that daemon to actually feed commands and have them executed by the daemon process. Well, how does that help? Well, first of all, the Maven Demon, as I said, keeps a JVM running and warm for you, which means you save on startup time. The JVM startup is still a couple of seconds. It also means you save a bit on parsing your project object model, and you save on loading plugins. And especially some plugins, for instance, the Kotlin compiler plugin, the Scala compiler plugin, they are famous for being a bit slow to load. And imagine doing that on every build. Well, the Maven Demon will actually do that once and then keep them in memory, so the next time you run your build, they will be readily available. The second thing, and this is really where the parallelization comes in, is that Maven Demon by default will run a multi-module build in parallel, but this time it will not clutter your output. Has any of you tried capital T with Maven for a multi-threaded build? Yeah, and be honest, we love the output, right? Because it's so helpful that everything is cluttered. And if something fails, then you really don't know where the stack trace come from, because yeah, probably it was 15 lines up or 20 lines down. You never know. Well, the Maven Demon actually addresses that by capturing the output and then only putting it into your console when the whole build is done in the right order. And the third way in which the Maven Demon helps is by including the smart builder developed by the friendly folks over at Takari, which takes the parallelization even one step further by looking ahead. Hey, what is the next module that I could possibly build at this point, and already enqueuing it for execution rather than waiting until the next moment would be there to run a new bunch of modules. So, when to apply the Maven Demon, because just like with parallel tests, this is not a kind of improvement that you can smash on your project and have a free lunch. There are free lunches, but not here. So when does this really help? It really helps if you have a large project, and by large I don't necessarily mean lots of source files, I mean a lot of modules. The more modules the better, I would even say. Imagine the code base of Quarkus, for instance, or such. They have hundreds of modules. And imagine having a beefy developer laptop. Well, then you can actually leverage all those CPUs that are just eager to do their work for you. Why? It's because you can modularize a lot of modules, and you have the parsing of your pom.xml to happen just only once. Second situation when it could be useful is when you have a lot of plugins in your build, because again, they are loaded only once for your whole build and also for the subsequent builds. And finally, when you have plugins that take a lot of time to load. I already mentioned compilers for Kotlin and especially Scala to be a bit expensive in terms of loading. But again, there's caveats that apply here as well. As I said, the Maven Demon will run your build in parallel over all the modules. And this may work in many situations, but some older plugins and some external plugins that are not maintained by the Maven team happen to be non-thread safe. Well, the name already suggests they are not suitable for a multi-threaded execution. So if you use the Maven Demon, or if you use Maven-T, this will potentially make that plugin execution fail. It was simply not designed to be used in such a situation. Well, the cheap solution is to say -T1, but say goodbye to your parallelization, because it actually says use only one thread. Better, of course, address the root cause. See if you're on the latest version of that plugin, if maybe they already made it thread safe. Report it to the plugin maintainers, or if you are the plugin maintainer yourself, well, fix it yourself, obviously. Second caveat that applies is that parsing the Maven config file, for instance, that could live in your .mvn folder, is re-implemented in the Maven Demon, and there are a few known issues there. So before throwing it out of the window because it doesn't work, maybe just check them out and see if those apply to you as well. How do we do it? Well, first of all, we install the Maven Demon. The Maven Demon comes, as I said, as a daemon process and a native executable for your operating system and your CPU architecture, so you really need to take care which package you download. Also, they come in two flavors, one for Maven 3.9 and one for alpha releases of Maven 4. So really take attention which version of Maven Demon that you download. Second, you need to retrain your finger gymnastics, because every time you typically use MVN, you now type MVN D. So the D, remember all, let's see, it's on my ring finger, so gotta make that into your finger gymnastics. But it's not that hard, trust me. And then finally, in order to inspect how the Maven Demon is behaving, it might be good to learn a few new tricks, like mvnd-status. You can see which daemon processes are running, which JDK they use, and with -d mvnd.buildTime is true, you get a simple report on the timing, and it will give a hint of, I think this is now the current bottleneck for optimizing your parallelization even further. And you can get an extensive report by doing smartbuilder.profiling is true. Okay, enough talking again. I think it's time to actually show how this works. And for that I'm going back to the terminal, cleaning up my environment here. Let's see, this is demo 3, I believe, isn't it? Demon, yes, there it is. Okay, the first thing we will do is, just to be sure, clean up the results of earlier builds. I'm already using Maven Demon for that because it's just way quicker. Okay, now I'm going to do a regular build using Maven 3 of Shiro up until the Shiro core module again. Again, those first 15 modules, that's long enough to already illustrate the improvement that we want to see here. What did we have last time?
1 minute and 27 seconds, I think.
Okay, so
we disabled parallel tests again, so this should be roughly the same.
Should be roughly the same. 1.5 minutes is our best guess that we can make at this point.
Of course, later you can combine these techniques.
If
but,
that,
for
if
now,
yeah.
we want to show the improvement of Maven Demon only. So this is a config module. After that, there will be the core module, and you can see the test again executing in sequence.
Yeah, as we expected it to do.
And there we go.
These are really like the most exciting parts of any talk, right? Waiting for a build to finish.
I'm excited to see the next part.
Yeah, I know.
Okay. There we go.
Perfect. Okay. To be really had to have a really equal playing field, we'll clean the build once more. And now we will be using Maven Demon. Well, the first thing that I immediately notice is that my console is not cluttered and spammed with output. It only says, okay, I will use at maximum 7 threads. So I figure you have an 8-core machine.
Yeah.
Because by default the Maven Demon will leave 1 thread open so that you one CPU free so that you can run Slack and all the other very important things on your laptop, right? I mean, so 7 CPU cores can be used, and at this point it's using 3 or 4, depends a bit on how fast I talk. We are at 80% with 40 seconds on the clock. Oh, 93%. Well, we might make it under a minute then. That's going to be close, right? It's going to be a close call here. Nah, it's not going to be under a minute. That's too bad. Still, it's the tests.
Yeah.
See, it's Shiro core surefire. Yeah.
We should have enabled it.
Yeah, that would have been fun.
At least our console wasn't spammed, right?
At least our console wasn't spammed, so that's the good part here. I'm surprised the test takes... Yeah, there we are. So, 1 minute and 20 seconds.
Dang. Okay.
It's an improvement.
I think it depends on the project, no?
Might be. So, is there a way that we can actually push our project into doing better
Martin,
way?
I'm glad you asked.
Oh, really? Go.
Yes, there's something. Parallelizing your build and Maven modules everywhere. Notice the Maven in front of the modules. We are not talking about JPMS. I need to hurry a bit because our time is running. So let's look at the sample application. This is, maybe you have seen it yesterday, hexagonal design. It doesn't really matter what you see here. You have some common ID classes, you have a lot of ports, you have some adapters. You might have seen it, you might have not seen it. There are some interfaces, some services, your typical application. So how do we slice Maven modules typically? If you go to any workshop or a talk, they will probably do something like this. So the whole core is called application-core in the middle. Then all the outgoing and ingoing ports are going into another Maven module in your Reactor project. So a command port maybe if you have it. Then all the outgoing ports, mail port, DB port, etc., etc. And all the adapters, which are the actual implementations, are going into their own module. This is typically what happens. So this also means for your application core to compile, you have to wait for the ports to be compiled. Yeah, this is a hard dependency. And before any of that can be compiled, in the upper left corner, you can see common ID classes, which are used through the whole application. And this is a big bottleneck, because this is a single module which will be compiled on its own, alone, even by Maven Demon, because there's nothing else, and everything else is dependent on that first module. So how can we improve on it? Maybe we can feed the daemon more modules. Okay, let's do that. It looks like this. It's a little bit hard to see on the slide, but I think you can make it out. So at the bottom, you see I ripped the extensions into their own Maven modules. So since they have no other dependency, in the first phase of Maven Demon compilation, you will compile the common IDs and the extensions, so 3 modules now, instead of 1 module in the first phase, in parallel already. So this is already an improvement. And in total, in this case, I have, I think, 14 modules instead of 9. And if you look at the command service, it can be compiled earlier because it now only depends on the command port, and all the services, or let's say a group of services in the middle, LDAP user service and maybe a role service in the same module, can compile on its own and is not dependent on waiting for maybe a health service or a GitHub service or whatever to complete. So you change the application, right? So what does this give us? Well, you can have faster builds with this approach, but only before there were not enough modules. Now you have maybe enough modules to parallelize your build. Maybe if you do it right, you can drop arc unit. I've seen this because now you have a lot of dependencies and you don't depend on the actual implementations anymore. So the test from one module cannot import implementation of another module, which is actually great and what arch unit is actually for. And it's easier to exclude transient dependencies because they are more specific. So maybe you want to exchange some dependency with another one. That might be helpful, might not, depends on your use case. And well, there are some cons. Well, you have a lot of new modules now, so you have to navigate them in your IDE. That might be a con. And of course, you need even more awareness than before with compiled scopes. So you have runtime scope, provided scope, compiled scope, test scope, etc., etc. So this changes. And yeah, it may not be suitable for libraries. Why? So it depends on your use case. So you have this trade-off from profits, because you have now a very quick compilation time versus added complexity. And for libraries, you have a consumer impact because their imports might change, their dependencies might change. So do you want to nag them with just you and your notebook compiling faster? I don't think so. But for applications, it might be useful. It does impact architecture. Do you want to go this way? I don't really know. But speaking of more modules, oh, no, wait, the demo first. I wanted to do a demo, but it's really hard because I don't know of any application which was refactored like this in one go, so I could show a before and after. But what I can show you is that it's not a good thing for libraries. So this is Shiro. Default is a little bit small, but I can I put the total time at the top. So it takes 2 minutes to compile on my machine. But if I merge a few modules, it doesn't change a lot because we don't have a lot of long-running tests, no big compilation classes. So it might not be suitable for every use case. So take this with a grain of salt. You have to change your application architecture. But speaking of a lot of modules, imagine one of your modules fails and you don't want to compile everything again. Martin, do you think there's something we could do about it?
I'm glad you ask. I'm really glad you ask. Of course we can.
Only 10 minutes left.
The thing is, builds will fail. Just like German cars. I'm sorry it was a German car. I can say that because I'm not German. The thing is, how do we proceed after that? Have any of you tried this suggestion from Maven? Like, oh yeah, sure, build has failed, -rf, whatever the module I was working on. Yeah, tried it, quite a few hands. And how often did it work? Sometimes. The two of you are lucky. The thing is, the Maven Reactor behaves a bit strange in this regard, because first it will trim your project list. The project list is then, we say -rf, so we say, okay, whatever that we were going to build, the whole of Shiro in this case, resume from Shiro core. Okay, everything before Shiro core is not necessary anymore, throw it away. Then, okay, Shiro core depends on Shiro crypto. I don't know Shiro crypto, never seen that one before. Build fails. That's why it doesn't work. So people got used to actually doing this, Maven clean install. We've all seen those readmes, right? To build a project, you first need to run Maven clean install, which is actually wrong. We're a bit short on time. Otherwise, I would advise you, let's all watch the story that Robert Scholte told on DevOps a few years ago. Broken builds and bad behaviors, the Maven story, where he explains this really thoroughly. That's really a talk I would like to recommend. But the thing is, we can do better. We want to be better. And you can with Maven 4. But the thing is, it's still under construction. If you are troubleshooting your build locally, or if you are performing test-driven development, then you can just run Maven verify, as you'd expect. And if the build fails, you can still do what Maven tells you to do. More on that in a minute. This doesn't make sense in any situation. If you are running Maven on a build server, well, there's no way to do interactive stuff. Because Jenkins or GitHub Actions or Azure DevOps or whatever you use, well, they will fill your build and you will have to resolve it there. This is really for local use. And there are a few plugins that are not maintained by the Maven team that don't really work that well yet with Maven 4. And there again, I highly suggest report it to the plugin developers and ask them if they can catch up and start supporting Maven 4. So with Maven 4, you will get a slightly different error message. I mean, your build can still fail, just like the German car, but it will say Maven args -r. And in this case, we're going to read that fine manual, and we are just going to do that like Maven verify -r. Note that you don't have to say where to resume from. Maven will actually remember for you where it last failed, and it will resume from there on. And it will just continue your build and still be able to resolve dependencies on earlier modules that you are not including in the build this time. So in a way, it helps you optimizing the work not done.
Can we skip the
Yeah, it might be good to actually skip this because we want to show you something more. Because when I say optimize the work not done, are there ways to optimize that even further and have even less work done?
Oh, Martin, I'm so glad you asked.
Okay, go.
Okay, so yes, there's something more. The Maven BuildCach extension, that's actually the official name. And so how does the BuildCach work? It does skip parts of the build and well, the parts which don't need to be executed. So it does this by using for strategies. It only executes parts of the build which change. Then it tries to find out which are, well, subtrees of that module and tries to build them as well. And it will also normalize the version, so you can actually use this across branches or forks with a different version number, and you will still make use of the cache. And you have product state restoration, so for example, you can configure the plugin to restore the artifacts versus repackage them locally, or whatever suits you best. And so, how does it know which parts have changed? Well, there's actually a hash over the POM.xml file, and if you change dependencies or their scope, or if you modify plugins, executions, configurations, etc., the cache will be invalidated because it now produces a new fingerprint or new hash code, and you will use a new cache. And there's also the modification of source code. Same thing, fingerprinting using hashes, and it will invalidate the cache and use a new one. So when do you want to use the cache extensions? Oh, this is going to be a long list. So you need to already use Maven 3.9 or Maven 4. This is a hard requirement. It doesn't work on 3.8 or earlier. Your product really should not rely on quirks. So if you are misusing a plugin in a way that you shouldn't use it, you might get interesting results. You might want to speed up your local developer build, then this might be good for you. If you want to speed up your CI builds, I read about pull request only billing the part that changed, which is, well, it actually saves a lot of cost and money. You might want to share your cache with your coworkers. Yes, that's possible. You can upload the cache automatically using the cached extension to, for example, WebDAV. And you're willing to invest time to make the cache portable. Now, I said earlier, some things may invalidate the cache, for example, command line arguments, I think too. So how do we install the extension? You already know the extensions.xml file. Just put the cache in there and you're done. You can optionally configure the cache configuration. Okay, now we're going for a demo. I think we are now going to arrive at rocket speed. I hope so.
Well, it's about time.
Yeah, it's about time. True. Okay, there is my demo, Maven 6 cache.sh. Okay, this is the first one. What do you expect to happen when I execute the whole Shiro project? Well, it's the first run. It doesn't have a cache yet. So, Martin, I'm sorry, this will take about 2.5 minutes.
Really?
Yeah, that's the first run. I can't do anything about it.
Yeah.
But I mean, now you can see the inner workings of Maven Demon, and if you compile a little bit larger project, we have 61 modules. It's at the 24th module already, and you can see that the concurrency is going up and down, which is actually great. And so I think the biggest benefit here is after Shiro Core, when it compiles all the samples, all the integration test modules, it will be a big gain. So we
or
have
at least it should be.
So this is sadly I need to compile the whole Shiro project for this to really work out the way we want to. But it's only going to be, oh, there we go. There are all the tests, the samples we wanted to see. Again, first run, no cache yet.
Maybe a question in between.
Yes, please.
You talked about the open telemetry Maven extend. Is it possible, or are there any limitations for us as a plugin developer to use the self-stated span possibilities? So
Repeat the question.
Can we create our own spans with it without any limitations?
Yeah, so the question is if you want your plugin to also benefit from the telemetry extension. I believe you can. The thing is, I've never done that myself before, so there's a bit of a disclaimer here. You probably need a dependency on that, on their API, and you might not want to enforce that upon your users. So I think you can check out their documentation, but even if you don't, then at least the execution of your plugin will be recorded as such. I see the build is through. 2 minutes on the clock.
2 minutes. All right. We're running out of time, so we really need to speed up this. I'm going to hit the enter button again. The cache is installed. What do you think? What will happen? Please answer no. Oh,
that's a bit too late.
huh? Interesting.
Not?
What happened here? This was not going to happen.
Oh, there it
we go.
was. Yeah.
Oh, the output is a little bit odd. Okay.
Sorry,
you
too
didn't
late.
answer quickly enough. So it took 0.2 seconds. I've never seen this kind of output actually. It's well, this is a live demo, right?
I think the output was so quick.
This never happened before. Usually it takes 0.6 seconds, not 0.2 seconds, and the output is in the correct order, but I've never seen this. We are going to report this upstream on.
That is nice.
Okay,
Nice one.
so
Yeah.
0.2 seconds. I think this qualifies as rocket speed, don't you think?
This is really optimizing the work not done, because I can't believe it actually did anything.
Okay, one more.
Which is by design.
Yeah, one quick step more because we are really running out of time. If we now modify a file in the web module, which is like the 16th module, and compile again, it will start at module number 16. It's now already progressed to module number 35 because it skipped all the previous modules.
In 5 seconds, really.
Yeah.
Okay.
Okay, so this is the cache plugin.
Yes.
So now, do you think we can do even better, Martin?
Even better, yes. But as you said, unfortunately, we don't have that much time left.
Yeah, just
Yeah, that's just all about the cache, right? So without actually showing them, there's a few honorable mentions that we would like to share with you. First is a really neat trick, which is low effort, high benefit in my experience, is reduce logging. In unit tests, it's enough to see either pass or fail, and if it fails, then you can investigate. In all other situations, just ignore logging. Saves quite a bit of time. Also, if you use frameworks like Spring, make sure that they don't create a new Spring context for every test case. That also saves a lot of time. Second is a very interesting showcase by Christian Stein, who wrote JUnit 5 Looming, which is an extension to JUnit 5, which actually runs parallel tests using virtual threads. So even more parallelization of your tests. And we just heard rumors that it might eventually merge with JUnit 5, so that you will get it out of the box as long as you have a modern version of Java running. But we all have that, right?
Yep.
Great. It's time to wrap up. I think all of us can now identify kind of as a rocket man. We learned a few things today. We learned how we can actually measure our builds, because without measuring, we're going to take the wrong measures, the wrong improvements. A fool with a tool still is a fool at the end of the day. Remember that. Then, what we can do, if we know where to actually apply these solutions, we can run tests in parallel within a module. We can use the Maven Demon to run our modules in parallel. We could even feed the daemon by pushing our architecture to create even more modules. But there's some caveats as well. If we are running locally, we can resume after a failure by actually reading the manual and optimizing all the things that Maven does not have to do. And we can take that one step further and use a cache of build outputs to actually skip all the work that has been done before and is not going to change. With that, we've come to the end, just in time for lunch. Thank you for staying with us. You can follow us on socials, and we are going to upload the slides. Also, all the demos are on GitHub. Check them out. You can run them on your local machine and see if they work the same for you. And you have a starting point once you have convinced your project manager or your scrum master to actually start doing these things as well. And if you have a tough time convincing them, just go playing outside in the hallway, just grab even more coffee during your day, and they will eventually be convinced. Thanks a lot.
Thank you.
If you have any questions, please find us outside.